Okay, this is graphing systems. All right, in this unit we're going to learn how to graph or review how to graph different equations and then see where the two graphs meet. All right, with our challenge question we talked about solving certain equations by writing two different equations and seeing where they meet. All right, where the total will add up in both. Alright, so for the first problem, we have y equals 3x minus 4. Alright, and this is good review for graphing. How do we graph this? Well, this is in slope-intercept form, which is y equals mx plus b. Okay, the first thing we did was we plotted b. In this case, b is negative 4. Or 0, negative 4, because it's on the y-axis. It's a y-intercept, it's on the y-axis. So we go down to negative 4, draw our point. The second thing we did was we found the second point from the slope. The slope, m, is 3, which is 3 over 1. Okay, so from our y-intercept we went up 3, 1, 2, 3, and then ran 1 to the right. Up because it's positive 3, and then right because it's positive 1. Once we have our 2 points, we could draw a line through the 2 points. Now I'm going to try to make this line as accurate as possible. You guys might need to use a straight edge. It is very important with this section to graph your lines as straight as possible. The second problem, 2x minus 3y equals 12, is written in standard form. ax plus by equals c. Remember, a, b, and c are integers, so they're not fractions. 2, negative 3, and 12 are not fractions. We are in standard form. Now, about a month ago, we graphed these. Okay, by graphing the x and y intercept. We would plug in 0 for x to find the y intercept. And I'll make this blue, which is actually the same as the y intercept for your other problem. And then we would plug in 0 for y to find the x-intercept. X equals 2. Alright, so our x-intercept, where the line crosses the x-axis, is at 6. Let me make that blue too. Okay, so we have our y-intercept and we have our x-intercept. Now that we have our 2 points, we could draw a line through the 2 points, as straight as possible. Okay. Now what we're going to do with this unit is we have our 2 equations similar to the 2 challenge questions. Okay, and I showed you what the 2 equations look like. We're going to determine where these 2 equations meet. And if you notice in this graph here, they meet at 0, negative 4. That's a common point between the 2 graphs. Alright, so what is a system of equations? Well, it's 2 or more equations. We're just going to work with 2. And we have to determine where they meet. We want to know where they meet or where they relate. Do they have a common point? So in this first section here, we're going to determine whether two lines have a common point or two equations have a common point. Alright, so the first example, example 1, y equals negative 2/5 x plus 1. That's our first equation. Our second equation is y equals negative x plus 4. We want to find out what common point do these two lines share. So let's graph them. If you notice, they're both in slope-intercept form. So again, we're going to plot B, which in this case is 1. Right there. So we're going to plot 0, 1. Go to our y-axis, 0, 1. Alright, and then we're going to use the slope. Slope is negative 2/5, so we're going to rise negative 2 and run 5. Negative 2 down, 1, 2, and then run 5, positive 5, so we're going to go right. 1, 2, run 5. Alright, and you don't have to draw the jumps if you don't need to. Okay, now it's very important to draw an accurate as possible line. I'm going to do my best. The second graph, we have a slope. a y-intercept, that's 4. So we go to 0, 4, 0, 4. And the slope is right here, negative 1, or negative 1 over 1. Here's our rise, here's our run. So from this point we go down 1, because our rise is negative, and run 1 to the right. Okay, and we're going to draw our line as accurate as possible through these 2 points. Not a great line. Alright, and then what we're going to do is we're going to analyze this. Where do the two lines intersect? Well, if I notice right here, probably should be where the two lines intersect. What point is that? That's at x is 5 and y is negative 1. Alright, and that would be the answer to our problem. Okay, if you notice, my lines aren't exactly at this point. They should be. That's why it's very important to draw your lines as straight as possible. Let's look at another example. Y equals 4x minus 8. So we go down to negative 8. B equals negative 8. So we go down to negative 8 on our y-axis. Our slope is 4. 4 over 1. So up 4. 1, 2, 3, 4. Over 1. There's our 2 points. Draw a line through the 2 points. Alright. What you might want to do to make your lines as straight as possible is plot your first point, go up 4 over 1, second point, and keep doing it. Up 4 over 1, because your slope's always going to be the same. Up 4 over 1, up 4 over 1, and I'm kind of off my line right here, as you notice. So let's fix it here. Negative 8, up 4 over 1, 4 over 1, up 4 over 1, up 4 over 1. Try to connect the dots as best as possible. Second graph. Y equals negative 1/2 x plus 1. B equals 1, or 0, 1. -1/2. So we're going to rise -1, or go down, and then run 2. 1, 2. Okay, notice how it shares this point right here. Again, with our points, we could go down 1 over 2 again, down 1 over 2, down 1 over 2. I did a pretty good job on this one. Alright, but our goal is to find this point right here, where the two lines intersect. And that point is at x is 2, y is 0. Alright, next practice problem, y equals 3x minus 1. Well, we spent a lot of time on slope-intercept already. So b equals -1 or 0, -1. We'll run through this really quick. M equals 3 or 3 over 1. So up 3, 1, 2, 3 over 1. Alright, and let's keep doing this just to make sure my line is straight. Alright, and remember, you can always go in reverse. So instead of up 3, 1 to the right, you could go down 3, 1 to the left. Down 3, 1 to the left. Down 3, 1 to the left. Draw your line through the points. Alright, there's our first line. Our second line, 3x minus y equals 6. Alright, this isn't in slope-intercept form, it's in standard form. So let's graph it using the x and y intercept. The x-intercept is when we plug in 0 for y. So 3x equals 6. X equals 2. X equals 2. For our x-intercept, our y-intercept would be 3 times 0 minus 6 minus y equals 6. This cancels. Negative y equals 6. Y equals -6. So we go to -6 on the y-axis. Alright. Now you're going to draw a line through the 2 points. Okay. But what you might want to do, alright, and you might already notice this, these 2 lines are pretty close. Okay, the change is 2 to the right and then up 6. So let's make another point. 2 to the right and up 6. Alright, what happens here? If you notice, the lines do not intersect. What do we call that when lines don't intersect? Well, that's called parallel. Alright, they're parallel lines that don't intersect. So if they don't intersect, then we can't find a solution. Therefore, the answer will be no solution. No solution. Alright, and if we looked at this equation again and tried to get it into slope-intercept form, subtract 3x, subtract 3x, negative y equals negative 3x plus 6, divided by -1, y equals 3x plus 5. Look at this slope, look at this slope. They are the same. Therefore, your lines are parallel.